Hello everyone, welcome to Rubber Industry NewsHour. This is a techno-based weekly online program for the global rubber industry. Namaskar, Sawadee. Welcome you all, and today we are having episode number 36. I welcome you to this episode number 36. In this episode, our focus is rubber industry tech talk, and the focus is on the rubber bonding and coating. So we are going to have the topics related to the rubber bonding and coating. In this one, we have two presentations. The first presentation by Mr. Michael Bonner is going to discuss about the controlling the rubber bonding process, reducing solvent usage, and improving outcomes. And we have Mr. Ravi Mahadevkar. He will be discussing the dry film lubrication, a new approach for rubber O-rings and components coating. So these are the two presentations we have in this episode today. After that, presentations are over. We will have a discussion, and in this discussion, we will be discussing various issues about rubber bonding and coating. You are welcome to post any questions you have. Both of them are well experienced and knowledgeable, not only about the presentation topics, but you also have general issues about rubber bonding and coating. I'm sure you'll get some help out of this session today. As you know, this program is managed by Technobase. Let me introduce about the Technobase and what kind of services we offer for the rubber industry. Please allow me to open the form. Technobase is based in Thailand, established in 2005, and it is recognized as an international resource center for industries and technologies. The foundation for Technobase is basically offering the professional education along with the business services. When it comes to services, we have a broad range of services. We have trade exhibitions, training conferences, webinars, business networks, publications, and also there is knowledge test, factory audit, technical consulting, and also business matching. So we have both education aspect of it and also various business services. And when it comes to the business focus, we have two segments, polymer and non-polymer. When it comes to the polymer, we have rubber, plastics, polyurethane, and also a little bit on adhesives, coatings, and non-polymers, we focus on the chemical engineering, energy environment, water and membrane, filtration, separation. These are areas we cover. Of course, we're all here in rubber. Rubber is one of the main segment of the Technobase activity. Our services are pretty much global. Let me brief you about what kind of services we offer for the rubber, latex, and tire industry. First of all, we introduce our exhibition, GRTE. This is basically the gateway to the rubber, latex, and tire industry in terms of markets and also knowledge hub. We have an event next year on 5th edition of GRTE, 29 to 31st March. Then we are also organizing the 2nd edition of the Middle East Rubber Expo. It used to be called Arab Rubber Expo. We changed the name to Middle East Rubber Expo, which will be held in Sharjah, United Arab Emirates, near Dubai, during the 21st to 22nd November. These are the two exhibitions. So please do check our website, expo.technobase.org, for more information on it. Along with these two exhibitions, we also, it's kind of co-located event. It's the rubber research and patents. We focus a lot, emphasize on the research, because research is the backbone of any of the industry development. So we promote rubber research and patents as a poster fair, as a part of the both trade shows we organize next year. We offer online training, rubber industry online training, and we through the NewsHour webinar project. You can always find more information at knowhow-webinars.com. This is we have developed during the COVID times. We have extensive online topics available, various issues about rubber, plastics, and polyurethane. For the rubber industry, we have more than 40 plus industry experts, specialists, the resource person offering various online training programs. These training programs we develop more than 250 short topics, which are 30 minutes to 3 hours long, and we also have master classes 1 day to 10 days long with 30 plus master class available, And we're about to announce for the 3-month executive diploma program, which is covering the non-tire industry. This is Executive Diploma 360 degrees, Rubber Industry Technology and Management. We're opening for registration for the next year in June, starts in June. As you see, it covers the technical aspects and also management aspects of it. And as a 360-degree means we cover, it's a total full circle of the issues related to the rubber industry. We have lots of books we have published, rubber industry books, and you can find all these books at store.technobiz.org. These are the books and 50+ reference books, and of course, what the books we publish is always the books which are not available in the market. We have our own publishing press, so we publish a number of reference books and pocket books. We do have a Rubber and Tire Digest magazine. This is a joint publication by Technobiz and Rubber World in the US. So it's currently available in digital edition. It's a bi-monthly. Currently, there are 6,000+ readers in following this Rubber and Tire Digest magazine. There's a NewsHour, as I mentioned, it is a weekly program. It has technical talks, market outlook, panel discussions, leadership and business conversations. I'd request all of you to follow in every Monday at 8:30 Thailand time or 9:30 Eastern Standard Time in the US. As we have this Rubber Industry Connect program, which is basically a channel, a branding platform for the companies to promote their companies in the social media of the Technobiz platforms. Other than that, we offer a number of technical consulting, plant audits, customer marketing, and also the hosting brainstorming sessions, best practice implementation. These are the various consulting services we offer for the rubber industries. We have groups, networks, professional network, managing the rubber technologies global network. Currently, we have 5,300 members by Facebook. We have on the LinkedIn 5,000 members on the rubber industry network. We also have the WhatsApp group, close to 3,200 members are there. So through this one, we reach out to all the rubber industry professional network. And we have video platform on YouTube, the Technobiz channel, all the rubber industry news server we post on the YouTube channel, the Technobiz channel. Feel free to check it out, our YouTube channel. Other than that, we offer digital marketing for the rubber industry. Anybody interested, if you like to promote your business through the digital marketing, we are here to help you. Okay. Currently, we're working on the Rubber Industry Digital Library as a literature resource for the rubber industry professionals. Within a few months' time, it will be available for the industry to access it. There will be articles, presentations, videos, pictures, brochures, all kinds of things we will be putting together in this digital library. This is a work in progress now. It will be announced soon. I think you already know this is me, and you can always contact me for additional information, anything related to the rubber industry or any other services you think we can support you. So that's about the what all about the Technobiz. Always check our website technobiz.org for more information. I'm happy to assist you. Just to give you some additional information on the upcoming event and the rubber industry upcoming events. One event is IRC 2022. It's an international rubber conference. It's going to be happening during 24 to 26 November in Bangalore, in India, organized by the Indian Rubber Institute. You can always find more information about it at irc2022.com. It has a workshops, conference, and also the exhibition. So feel free to check more information at the irc2022.com. Okay, let's welcome you all to the Rubber Industry News Hour, episode number 36. In this episode, we are focusing on the rubber bonding and coating. Let me introduce our first speaker, Mr. Michael Bonner. He is the Vice President, Engineering and Technology for St. Clair Systems, based in USA, a lead supplier of the process temperature and viscosity control equipment for industrial fluid dispensing systems. He is an electrical engineer. Over the years, he has spent in a wide variety of industries, including audio systems, medical equipment, HVAC, and also appliance controls, metal stamping, and even the manufacture of gasoline pumps. For the last 25 plus years, he has focused on the science of point of application temperature and viscosity control in fluid dispensing processes. So let's welcome Mr. Michael Bona to give a presentation on the controlling the rubber bonding process, reducing the solvent usage and improving outcomes.
Excellent. Well, hey, thank you for allowing me to be here today, and welcome everyone. Let's get right down to business. We all understand the importance of automation as a means of improving application process control. This usually brings to mind images of robotic spraying parts with very high precision. But there are other forms of automation that complement both manual and automated applications that improve process outcomes and thereby increase predictability and repeatability. So today in this presentation, we're going to talk about these less evident tools and how they can be utilized with bonding agents to improve the overall performance. As Param mentioned, you may not be familiar with St. Clair Systems, but we design and manufacture advanced point-of-use temperature and viscosity control systems for industrial fluid dispensing processes. We've been doing this since 1990. Over that 30 plus years, we've amassed more than 3,500 active installations all over the globe. I often joke that we have applications on every continent except Antarctica. But we specialize in both recirculating and dead end systems, and we handle everything from low viscosity materials like water and solvents that are down around 1 centipoise, all the way up to high viscosity sealers and adhesives that are in excess of 1 million centipoise. To handle these applications, we have equipment that can work all the way up to in excess of 400 bar. So who cares? And the answer is lots of folks across myriad industries, as you can see here. Each one of these demanding manufacturers uses fluids in their process, and they're critical to the outcome of their product assembly. Each one of them has had specific issues with those processes and come to us for solutions. Each successful project with customers like these increases our understanding of the ramifications of temperature and viscosity across a vast array of fluid dispensing applications. Now, this is a shameless advertisement for St. Clair Systems, but because many of these are critical coating applications, it's also the reason that we're qualified to be here today discussing this topic. We build all different kinds of systems. We build systems that consume a large room, okay? In this instance, these will be over 10 meters long and weigh more than 3,000 kilograms and cost upwards of $500,000. And those are the big systems, but we also build smaller systems as well. This is a thermoelectric unit. It can sit on a tabletop. It is basically 40 centimeters square, and it weighs less than 15 kilograms and costs less than $5,000. So it's a vast variety of different systems for virtually every application, regardless of size. And then we have a line of viscometers, and that includes our VTS inline unit, which is shown here. It's designed for continuous in-process control. It has no moving parts. It's constructed entirely of 316 stainless steel, so it's compatible with every process fluid out there. It's just 21 centimeters long and 6 centimeters in diameter, so it's small enough to fit easily into virtually any dispensing system. And this allows you to eliminate the uncertainty of manual viscosity measurements and manual adjustments for less than $5,000. And of course, we're proud to announce that we've successfully incorporated St. Clair Systems India Private Limited with our home office and assembly plant in Kolhapur. As Ravi often says, this gives us the ability and our customers in India the opportunity to obtain Western technology and quality manufactured in India at Indian prices. So you can check out the website there, www.stclairsystems.in, and you can get more details there. So let's jump into the topic for today, enough of the introductions. We're going to start by talking about the temperature viscosity relationship. This is the fundamentals behind what's going on. And these are the things that create issues in dispensing systems in the first place. We're often asked why we focus on temperature. And the answer is that temperature affects viscosity. And viscosity affects flow, pressure drop, volume of the dispense, and the ratio in the case 2K materials. But most of all, the spray pattern. As we can see here, we can see how the spray pattern changes with a width increasing proportional to the temperature. But this phenomenon, even though it's related to temperature, it's actually caused by the change in viscosity. So that begs the question, what is viscosity anyway? And it's a really good place to start our discussion. I like this explanation because it's simple. The property of resistance to flow in a fluid or semi-fluid. Now, we all understand that water is a consummate definition of a fluid, but what's a semi-fluid? And because you're all in the industry, you probably have a lot of things popping into your head that are specific to your particular process. But I'm going to pick something a little more general, something that you maybe didn't think of. Honey. Think of honey if you place it in the refrigerator. It gets thick, really thick, almost solid. But if you take that honey out of the refrigerator and you place it out in the hot sun, it starts to warm. And as it warms, it thins out significantly, and soon you can pour it, almost like water. Now, the change in how it flows represents its change in viscosity. And in this case, like we'll discuss all day long today, the cause of the change in viscosity is the change in temperature. For instance, here we see the viscosity versus temperature curve for Parker-Lord's Hemlock 220, which is a common solvent-borne bonding agent. And this was measured in St. Clair Systems India's lab. It's the typical curve we're all familiar with, okay? The viscosity is falling as the temperature increases, and though it looks like a linear relationship with a slope of about 0.9 seconds per degree C, if we apply a linear trend line, it reveals that just like with most modern coatings, this is actually an exponential curve. Now, another interesting fact is that Parker-Lord's DS3105 datasheet recommends that this coating be applied at a viscosity of 22 to 28 seconds, which if you look at the scale on the left here, you can see that it's below the minimum value in this data set, which means that this compound must be diluted if it's going to be sprayed. Now, this same data sheet recommends that this coating be diluted with 25 to 50% xylene. And from this graph, we can see the viscosity versus temperature curves for various dilutions of Hemlock 220. Again, these were prepared by St. Clair Systems India in their lab and measured there. Now, if we project the recommended spray viscosity range of 22 to 28 seconds across these curves, we can see the importance of the interaction between dilution and temperature in the actual viscosity of the fluid. It's apparent that depending on the temperature, dilutions as low as 5% can actually be used, whereas dilutions of 25 to 30%, which is on the low end of the recommended range, can produce viscosities that are actually outside of the recommended range. It also seems pretty clear that dilutions greater than 30% will produce viscosities that are below that recommended 22-second minimum for spraying across nearly all temperature conditions. So this is a really important finer point about the compound and its usage. But what many people don't think about is that adding solvent alters that carefully developed coating formulation that Parker Lord worked so hard to create. And the solvent creates many issues within the application process. Now, first, it represents excess cost because every drop of added solvent has to be driven off in the oven during the curing process. And in addition to the environmental concerns, it also represents a risk to our operators. Now, to make matters worse, too little or too much solvent can cause defects. And we can plot these defects on a continuum as we see here. Now, if we have too little solvent, we get dry spray and all of the associated issues with adhesion and all of the other issues that you're used to, uneven coatings, etc. If we add a little more solvent, we reach the optimal point at which we should be using the product to get the optimal performance level. But if we continue to add solvent, we begin to get issues with cure, which, as we add more and more solvent, can progress into problems with adhesion and blistering, and as we add more solvent, even solvent pop. This is why the temperature factor is so important. It's important to understand the impact of viscosity in our process. Proper coating viscosity is key to successful product outcomes. Yet, even in today's modern applications, we usually make one viscosity adjustment and it comes at the beginning of the process. And we usually make that adjustment by adding solvent. And we generally ignore the impact of temperature on our process outcomes. Now, there are a lot of factors in our environment and in our process that affect temperature. And things like ambient temperature, which is the first thing you think about. What's the ambient in the room? But there's also the coating storage temperature. What temperature did you store it at? Did you store it outside in the hot sun? Did you store it inside where it's cooler? What's the volume of the source container? That's important because it's a thermal mass and it takes a long time for a thermal mass to change temperature. And then there's the rate at which the coating flows in our process. And if we're recirculating it, it's the rate of recirculation. And what's the path of the recirculation? Does it go up through the truss level and down to our dispensing station? Or does it flow maybe under the floor in a basement area where it's cooler? The path and the recirculation rate and the dispense pressure also all add together to determine the type of pump that we use and the energy that pump puts in the form of horsepower. While we know that the pump adds heat because it's adding energy to create motion, it's doing that in opposition of shear, and there's shear in all of our systems. There's the pump, the agitators, there's regulators, there's nozzles and fittings, and all of these add shear to our fluid. Shear equals friction, and friction equals heat. Therefore, shear equals heat. So all of these factors play into changing temperature in our process. And of course, we never want to forget the substrate temperature because it's also important to the overall application process. So how do all of these temperature influences affect the film formation? If we're going to discuss film, we need to start with the perfect film. If the viscosity can be controlled and the system set up such that atomization and deposition and film build are even across the part, the cure will also be even and the result significantly more predictable. This more consistent surface will also produce a better bond. Not only will the bond be stronger, but the layer will also be significantly stronger as well. But creating the perfect film requires perfect conditions. And more often than not, conditions are not perfect. As we've already seen, if the fluid temperature is wrong, it will affect atomization, spray pattern, flow out, etc. The result is an uneven film across the surface of the part, as we've demonstrated here. This can have a significant impact on our film cure. As we can see, the thinner film areas are going to cure more rapidly than the thicker film areas, and that makes perfect sense. The uneven surface will also have a negative impact on our bond performance. It's also possible to create blisters from solvent entrapment under the cured surface of the coating. As it cures, the solvent gets trapped and blisters form as that solvent tries to evaporate up through that sealed surface. And this has a negative impact on bond performance in the Hemlock layer itself. Now, to make matters worse, if these thinner film areas that we're looking at are within coating spec, the thicker film areas represent excess coating. And when we apply excess coating, we're adding to our costs. So that's really important. Now, these things all add up to create defects, okay? And what defects do we attribute with these temperature-induced changes in the Hemlock and primer viscosity? And they're all the same ones that you're used to. First, there's the interlayer failures. These are the result of poor bonding between the substrate and the primer and the Hemlock, and the Hemlock and the rubber itself. So there's three different transitions there where these failures can occur. Then there's the intralayer failures. These are often called cohesion failures. And these are the failures that happen within the layers themselves. These are all caused by temperature-based viscosity variations that manifest themselves as variations in film. So we have to establish our desired dry film thickness range. Okay, now on the data sheet provided by Parker Lord, the primer should be applied at 5 to 10 microns as a dry film thickness. Now the top coat should be applied in the 18 to 25 micron range for a total dry film of 25 to 30 microns. Likewise, if you're doing a single coat, it too should be applied in the 25 to 30 micron range. These are the optimal film builds to get good bonding and optimal film strength. So let's return to our film build example here, and we can see that we have a film thickness range between 25 and 30 microns, okay? And the areas below that 25 microns, as shown here, will have insufficient film. And it's hard for our rubber to actually get down into those cracks and crevices. So it creates a bonding issue, okay? This is our interlayer bond issue. Conversely, the areas where we're looking at too much film being applied, okay, this is above the 30 micron range. And this compromises the strength of the layer itself. This is where we get our intralayer failures, where the failure actually occurs within the Hemlock layer itself, not at the bond line. So our goal must be to stabilize and optimize the viscosity of the coating material at the point of use, which in spraying systems is the nozzle orifice. Now, in order to get a predictable film repeatedly, no other material temperature in the system matters as much to the outcome of the coating process. So how do we manage that? And here's an example of our bonding agent temperature control system installed on an automated spray system. It's an ideal solution because it is low in cost, it's small in size, and it has both heating and cooling capability, which is important because it allows us to maintain consistent temperature regardless of changes in the ambient from morning to night and season to season. It's got a low power consumption, which makes it economical to operate on a production basis, and it utilizes our recoilable coax hose technology to carry the temperature control all the way to the gun to establish point of application control. And that's very important to maintaining consistency through our manufacturing process, from day to day, morning to night, season to season, and importantly, from batch to batch. And it also works well for manual applications too. So if you're spraying by hand, this can help as well by making sure that you always get the proper atomization and fan pattern, and that eases the stress on your operators. So, when is temperature and viscosity control necessary? Well, when you're dispensing a viscous material that's sensitive to temperature changes. When manual, automated, or robotic equipment is being used. When repeatable results are not just desired, but required. when quality requirements are high. And so in short, always. What we stress is that you take your bonding layer from this to this. And the benefits are obvious. You get improved quality. You get increased first pass yield, reduced bonding agent usage, reduced primer usage, reduced solvent usage. So that adds up to cost savings. But that's extended because you also get reduced rework costs and reduced scrap costs. And best of all, for your relationship with your customer, reduced warranty costs. And then to help our planet, you get reduced environmental impact. And to benefit your operators and their families, you get reduced operator exposure. And so with that, I'm going to wrap up this section of the program and turn this back over to Param and allow us to move on.
Thank you, Mike. That's a very good informative presentation on the rubber bonding, controlling the rubber bonding process, reducing the solvent usage, and improving outcomes by Mr. Michael Bonner. If you have any questions on this presentation, you can post your questions in the question box. We will address in the discussion session. Feel free to post your questions. Rubber industry tech talk. Now the topic is on the dry film lubrication, a new approach for rubber O-rings and components coating. This presentation will begin by Mr. Ravi Mahadekar, who is a managing director of the Summit Engineers and Consultant Private Limited based in India. Ravi is the founder of this company with more, I think, completing close to 26 years as a designer and a manufacturer automation integrated systems. Since 2005 onwards, they have manufactured and delivered more than 1,500 coating machines within India and also export to many parts of the world. And they have collaborated with the St. Clair Systems in the field of temperature and viscosity control and monitoring system solution provider. So let's welcome Mr. Ravi Mahadekar to make a presentation on the dry film lubrication, a new approach for rubber O-rings and components coating.
Hello, everybody. This is Ravi Mahadekar from Summit Engineers and Consultants Private Limited. This company is engaged into manufacturing of adhesive coating machineries since last 26 years. We have got more than 1,500 installations worldwide. Customers with a customer base of about 500 plus. These machines are being used mainly for the adhesive coating application and the rubber to metal bonding. We came across this dry film lubrication applications and all, wherein we have been able to offer the single solution with the total applications. I'm specifically talking this word as a single solution with the different applications and all. Because if you look into the application wise, there are many areas where the solid film lubricants are being used. In the industries, you will find the wet lubrications as well as the dry lubricants. But the solid film lubricants, which are very importantly used nowadays into the industries. Automotive is one of the most important industry which has been using this as a solution for the problems they have been facing. Friends, I would be discussing some of the aspects of this solid film lubricants with you and try to enter into this particular technology, which is little not being used into many countries actually, right? So what do you mean by solid film lubricants? The solid film lubricants are the dispersions of solid lubricants in solution of inorganic or organic resins in solvents. And after application on the material surface and the following drying curing step, a dry bonded wear resistant lubricant coating is generated. Very importantly, people are nowadays looking out for a process which is more sustainable process. And this is the one of the important aspect I would like to define here in the form of solid film lubricants as a sustainable process. As I mentioned you that applications in the automotive is one of the very important and prominently used areas like wiper, motor bushings, steering columns, exhaust hangers, suspension bushings, and whatnot. The more and more, if you look into that, the elastomer seals is the most important and prominently used application where this dry film lubrication is being used. Look, a simple question: why one has to do the lubrication? Maybe somebody would be saying that, okay, I want to use it for the maintaining for a longer period or during the assembly part of it. It should be able to do the appropriate type of assembly forces requirements and all. So many more facets are there for which one has to think of that. So obviously, for any solid film lubricants, the main task is to the dry lubrication, the reduce the friction and wear. This is very important perspective. Lubrication under extreme conditions. You can find it out, especially when you are applying this, assembling the oil seals or the O-rings onto the shafts. This is a very tricky method one has to adopt in the absence of any kind of dry lubricants. Or you'll have to apply for the oil or the grease. The moment you use the oil or grease, you're going to get a problem of contamination onto that. Okay, and that is again the cleaning and other process are going to get added into that. The lubrication in areas where oil or grease are not suitable. Many times our rubber material is not capable or suitable for the oil applications or the grease applications. In such cases, what do? You do not have any other option but to go for the solid film lubricants. Some of the customers are using a talcum powder or the dry powders during the for the assembly part of it, but that also has got environmental issues related to that. Obviously, running in the optimization, emergency lubrication in combination with the oil or grease. This is a very important perspective, especially when you look into the seals or the oil seals or the piston seals, which are being used into the cylinders. It could be the pneumatic cylinders or it could be the hydraulic cylinders, where you are being oil assisted application, and then it can be the fantastic solution with a better life and the better results for you actually. Obviously, the corrosion protection and the chemical resistance and the noise reduction. These are some of the main tasks these solid film lubricants are doing it over here. As I mentioned, now when only restricted to the automotive, nowadays many customers are insisting to go for the threaded fasteners or the screws with the dry film lubricants. Obviously, elastomer is one of the important aspect of it. Lifetime lubrication, assembly, running in, and the noise reduction. So obviously, all these parameters or all these things are being utilized very effectively in the day-to-day automotive applications. For example, now somebody is also talking about it, the e-vehicle, e-mobility and all. And that's where the belts are obviously the very important perspective. Some of the customers are now talking about it, coating with the belts, the specialty coatings with the belts, the boots, bumpers, bushings, diaphragm. So many number of applications, enormous applications, which we will be able to see when it comes to to the level of dry film lubrications. And why not? This is one of the very important aspects one has to define, especially looking at the benefits of these coatings. It is ultra thin and lightweight coating, excellent moisture, chemical, and solvent barriers. It does not have the much of any impact on that actually. This is excellent dielectric property it has got, superior thermal stability, excellent ultraviolet stability, excellent creative and multi-layer penetration, minimal mass addition, which are making the dry film lubrication as the most popular and the most expected technology in the field of today's automotive or the rubber industries people actually. So usually all these dry film lubricants are the fluoropolymers. So usually what is this fluoropolymer coating actually? This could be the one of the simple question one must be having in the mind actually. Basically fluoropolymer is a polymer that is based in the fluorocarbon and has a the fluoropolymer is a strong carbon fluoride bonds, chemical compound that contains many strong carbon fluoride. Polymer is the property of not, this is very bonding easily with the other materials, very important. That's what makes the fluoropolymer a non-stick. And when you go into the rubber or the metal with this important perspective, one has to keep it in mind. Polymer, this is so it is basically not a and it includes many other products and the trade names could be Xylan, Algopharm, Exile, Solaf, Flucon, or PTFE kind of things which has been used into the industry part of it over there. So lubrication of rubber material, it basically conventional methods are also good. I'm not saying bad, but they are very low friction values. It has got very low friction values. It has got a high wear protection. Interactions with the rubber material is another big question for you actually. Many rubbers are susceptible for the oils, susceptible for the greases. So an application on the single components can create some effective utilization of this process as well. But the aging process is the very fast for the conventional lubrication part of it. Whereas when you really go for the solid film lubrication coatings, they are the dry and the touch proof. You will not be able to feel that it has been lubricated. Okay, but the compatibility with the rubber material is very easy and very effective actually. The mass part application is very much possible, unlike the oil application or the grease application with reference to your conventional O-rings and all. Then this is one of the best and advantageous process, especially while we are talking about its cycle reduction into the assembly times and all. The long time storage of the coated parts. The most important feature, the life, the solid film lubricated parts can have the life of shelf life up to 2 years or more than that. Obviously, the low friction value is at less than 0.04. The limited use in the dynamic application. When I say the limited use in the dynamic application, it is without the assistance of the oil. Okay, with the help of the oil or the lubricated materials, this is the very effective which has been used in the nowadays applications of the cylinders, and maybe the brake cylinder, the wheel cylinders, or the hydraulic cylinders and pneumatic cylinders and whatnot. So in general, what are the solid film lubricants? What is SFL coatings actually? The solid film lubricants are dispersion of solid lubricants in solutions of inorganic and organic. I previously just defined this. Now, nowadays, most of the time, people are talking about the sustainable process. And to make it more sustainable, we should be able to try to use the appropriate type of material. There are three main solid lubricants: molybdenum disulfide, the PTFE, and the graphite. So these are the three major solid lubricants which are being used into the industrial applications. Of course, not only the industrial, but also for the food, pharmaceutical, as well as the food grade industries, also these type of solid lubricants are being used actually. If you compare the comparison of this molybdenum disulfide, graphite, and PTFE in terms of the mechanical properties as well as the strength, the chemical properties and all. So as far as the strengths are concerned, all the three are equally good, or as far as the load carrying capacities are concerned. But the molybdenum disulfide is one of the most load carrying capacity, and due to which it makes it more suitable for the aeronautical applications, especially for the metallic components, which can be coated more effectively with reference to the molybdenum. Low friction, good adhesion behavior, which can be overcoated. These are the certain advantages, but at the same time, it has got a disadvantage like higher friction values at low pressure and distinctive running in the behavior part of it. Obviously, all the time it is going to be the black color. You cannot add any kind of pigment into this, and that's one of the disadvantage. While you try to make it nowadays, when the Poca ecosystems are there, you cannot be able to make it over there. The graphites is another important element or the material which has got a fantastic temperature resistance. It can go up to 600 degrees centigrade to conductive behavior of the graphite, which makes it more suitable for the engine components, especially when you want to go for the components related to the engines and all. For example, your piston are being coated with the graphite, but it has got a weakness as well. The whereas molybdenum disulfide, and the third one, which is the PTFE. This is one of the important material which has been used applications. It has got a low friction values at low pressure, good anti-adhesive properties, high chemical resistance. This is one of the important perspective which makes PTFE as the effective material for the coating applications actually. The excellent corrosion protection, electrolytically insulating, and it can be colorless or the white. Important thing is that it can be utilized with the colors or the pigments added, and we can make it with the different colors, especially for the application wise. Typical example I would like to give it that if suppose you want to utilize for the just example, the synonymity point of view, what will happen if suppose you are going to put the engines inlet and the exhaust o-rings actually. If by mistake, if you are going to put the exhaust side o-ring to the inlet side, then it will be blast because it will not withstand the other way around. So if we are by making the color coding kind of things over there for the o-rings, then it could be very easy for you to identify that. So this composition of the solid film lubricants is the solid lubricants, that is the powder form, which is normally available in the powder form, MOS2, molybdenum disulfide, graphite, PTFE. Then certain binders, the solvents, it could be the organic solvent as well as the waters, and the additives. Depending upon another perspective, the corrosive behavior or the wetting or the preservatives or the ultraviolet additives, these additives can be added by the manufacturers. no need for you to go into that. Only thing is that you should be able to choose the appropriate type of material and do the application part of it over there. This will give a brief explanation how this solid film lubrication behaves actually. Whenever the substrate is being applied with this solid film lubrication, the phosphated material, the material will be going inside the binders, the color pigments, and the phosphated layer will be covered in the form of solid lubricants. Now, whenever it is being applied with the another material or the operating surface, then this operating surface will be in a position to get it self-applied onto the surface, and that will be uniformly getting. On the right hand side, you will be able to find it out, the typical behavior or the typical photograph of the scanning which has been made into the microscope. The before application or the immediately after application, and with the solid film lubrication when the surface is being applied over there. So this typical type of behavior will be happening into the coating application. The most important parameters, the elastomer. Now I would like to go for the application point of view actually. The oil seals or the O-rings. The O-rings are very important. Normally they are made of EPDM, NBR, or the FKM and all. So many such kind of different material which are being manufactured with the injection molding or the compression molding process, and usually they are 10 to 20% of the cross sections are compressed for the application when you insert it over there. Now you can imagine, for doing the forces required for that will be enormous, and that is going to create a difficulty for you to do the application part of it. There are certain pros and cons of the different elastomers actually. The NBR has got a good resistance to oil and the fuel, but it has got a poor resistance to the aromatic and the polar solvents. EPDM has got a good resistance to heat, hot water and polar solvents, whereas poor resistance to the mineral oil and the fuel. FKM is a very good resistance to heat and the chemicals, but it is a poor resistant to the hot water and the polar solvent. So now if you look at the positives and negatives of that, and as a manufacturer, obviously the normally FKM will be the very expensive material, and if you want to achieve the certain desired qualities of the FKM thing, FKM rubber, maybe you can use the EPDM or maybe NBR rubber can be utilized, and by doing the coating you will be able to achieve the desired properties of the O-rings and all. So this is one example I'm just giving it over there over there. The sealing industries require the solid lubricants for dry or no adhesion of impurities. Pre-coating of a large number of parts at a time should be possible. Storage of coated parts, running in improvement should be there. Optimization of the assembly, wherein we should be able to have the Pokake system, reduction of the assembly force, protection from damage, and the separation of parts prior to, that is the Pokake system, we have been talking about it. And the lifetime protection, the wear protection. We have taken certain examples over there, wherein we have just given applied without coated O-ring and the with coating O-ring. The blue, if you are able to see here, the blue graph, which is showing the maximum force of about 250 Newton approximately, which is required for the insertion of the oil O-ring into the shaft. Whereas with the PTFE coated O-ring, you will be able to find the less than 50 Newton force, which can very well define the friction force has been reduced. Then the slipstick force or the stick slip force. Usually, while inserting the O-ring into the shaft, it will not be going in the straight. It will go in a slip in the stick type, and which is called as the slip force. the blue colored graph is showing the normal rather uncoated O-ring, and whereas the red one showing it's almost straight line graph. It shows that the stick slip force is almost zero. Obviously, the increase of abrasion resistance. These are all the experimentation and tests which has been showing, just to get you a brief idea about the benefits what we are going to derive over here actually. In the sealing industries, you'll be able to find the O-rings for the connectors, O-ring for the solar cells, O-rings for the thermostats, O-rings for the phase sensor, especially for the automotive, oil sensors. So many other applications where this PTFE coating or the dry film lubricated coatings are being applied over there. Into the sealing industry, you can see the fuel lines where this same material has been used and the life has been extended to the larger extent over there. Air injection manifolds, air intake pipes, where you'll be able to find the assembly becomes very critical. And many times the failure of the O-ring happens during the assembly itself, which can be avoided very effectively by using the PTFE coated or the dry film lubricated O-rings. Normally, these dry film lubricant coated O-rings are called as the PTFE coating or the molybdenum disulfide coating part of it, which has been used into the industries. These are some of the examples which are I'm giving it. Probably one or two of your components which could be requiring such kind of requirement, and you should be able to think of adopting this particular technology over there. Then the crankshaft seals. This is a very critical and important component, and which is very difficult to do the assembly part of it. And if suppose this is coated with the PTFE or the dry film lubricant, then the assembly becomes much easier. Some of the customers have experienced the assembly time has reduced to the tune of 10% as compared to the conventional crankshaft seal fitment point of view actually. Obviously, these plug and seal connectors which are being used over there, then the automotive seat application, locking, latching arms, so many. So all these kind of components which are being used into the industry are utilized nowadays with the dry film lubricants. So what is the coating process? We have just understood the general, the PTFE coating and all. This is very important to understand. Just like for the any other conventional adhesive coating applications and all, the cleaning or the pre-treatment is very important over here into this dry film lubrication coating as well. Then the coating application, drying, and the quality control. Just like your any other coating process, this is also going to be the useful. The same process will be adopted over here. Now, the surface cleanliness is a very important perspective for the dry film lubricants. In reality, a material to be bonded will arrive with the surface that has been contaminated. This can include the dust, oil, grease, fingerprints, or any other debris capable of winding up on a surface. Especially for the rubber or the metal, whatever the type of components you have been considering, it is required to be pre-treated. Or the surface cleanliness, the cleaning could be just by way of the hot water, it could be by conventional water rinsing or the soap alkaline cleaning. A variety of processes are there actually, right? And this particular contamination can, if by chance it is available, that can result in the reduced contact between the adhesive and the substrate, the preventing the bond failure. Okay, or the proper bond will not be happening. The detactified adhesive preventing the effective wet out and reduced bond strength. So all such kind of things can be avoided by utilizing the effective wet out. Okay, when we are talking about the effective wet out, this is just explain it with the help of this figure over here. The clean surface allows for the maximum wet out and the surface contact potential, and whereas if the ineffective wet out is there or any dirt or the dust is available, then that is not allowing you to have the effective adhesive over there. And this contaminated surface inhibits the surface contact and the wet out potential, which is creating the problem for you. One more aspect of this is the surface energy, especially for the rubbers. Normally rubbers or the engineering plastics, it has got a lesser surface energy. Okay, so by doing the cleanliness, by adopting the cleaning process and all, we are able to increase that surface energy part of it also. But apart from that, there are few more components, especially certain rubbers, which has got the very less surface energy, and for which one has to go for the plasma treatment. And plasma treatment is very expensive, but this is the much needed. And or alternatively, one has to go for the primer coating onto the material for that actually over there. The applications processes are a different process. It could be the deep coating, it could be the drum deep coating, or the spray drum. But as you every system, every coating system has got a different limitations, or the mostly nowadays the people are using the spray drum coating into this kind of application. Because of the advantages, it can produce the mass production is possible. It can handle one drum itself into adjustable coating thickness is very much possible. The thickness coating thickness ranging from 4 microns to 20 micron, it is possible to achieve into the drum coating application. With the homogeneous coatings, it is most suitable for the most of the SFL coatings, and color O-rings coating is also possible over here. This is just one example of the operation part of it. You'll be able to see here how quickly one will be able to do the coating over here. This is the fully automatic machine being used by a single person. So normally preheating, then the coating application, drying in a sequential manner. This can be done over here. By doing this, we are also ensuring the appropriate air circulation system within the system over here actually. In the cyclic manner, the preheating, by preheating, you are removing the water content onto the components, then the application of the coat, and again drying. So if you want to have the more coating thickness, then your required coating application, or the coat application, or the spray application will be more. Number of cycles will be more onto that. And the loading unloading becomes much easier without any intervention by the operator, which can result the components, ready to use components available for you. Now this is basically for the oil seals or O-rings or the round shapes and all. We have got what happens to the geometric components or the flat components and all. So we have got another solution for that, which can be, usually people are using the XY axis coating machine. We call it as a robotic coating machine actually, wherein you can have the variety of components can be coated into that spray area. Again, you will have the adjustable coating thickness, homogeneous coating is possible, and the coating in the color flat components coating will be possible to achieve it here over there. Here, again, you will be able to see that the basic parameters over here for the gun is a fixed one over there, but the angle and the nozzle diameter are going to be the very important for the spray coating applications for you. While you have been choosing an appropriate type of application method, and if you're going for the spray application, you must be able to choose the right type of nozzle diameter for the spray gun. Obviously, the variety of guns are available into the market, and you should be able to utilize the proper knowledge and the MSDS or the application data sheets by the manufacturers before choosing the appropriate type of guns over there. Obviously, the coating thickness, when I say that you are able to get 4 to 20 micron coating thickness and uniformly over there, it is possible, and this coating thickness is a function of the coating speed and the flow of the liquid or the flow of the coating material, which is being utilized over there. So while you go and choose the appropriate type of things, you should be able to decide these parameters and then go for the application part of it. Thank you.
Thank you, Mr. Ravi.
Over to you. Piram?
Yes, yes. Okay, that's the presentation on the dry film lubrication, a new approach for rubber O-rings and components coating by Mr. Ravi Mahadukar.
Hello.
Yes, can you hear me? Okay, now move on to the yes, we are here. Can you hear me?
I can hear you, Param.
Yeah. It looks like the signal issue with Ravi. Okay, guys, now we are into the discussion session on the rubber bonding and coating. We have received a couple of questions already from the audience, so we'll address them appropriately. May invite Michael as well as Ravi to open the cameras, join us. Welcome back, Mike. Ravi, can you open your camera too? Okay, good. I'm going to show the question on the screen for you, and you address them appropriately. Yeah.
Any questions?
Yeah. Mike, please. Do temperature.
Go ahead.
Yeah, maybe you repeat the question for the audience. So they first read the question and answer it. Yeah. Okay. Yeah.
Okay. Do temperature changes affect automated systems? And the answer is absolutely. If you think about automation, it's based on repeatability and the ability to do the same thing over and over and over again. And while a manual operator, say spraying a part, has eye-hand coordination, automation does not have eye-hand coordination. It can't make adjustments on the fly. So changes in spray pattern or in spray consistency, atomization, things like that happen as a function of temperature-based viscosity changes will have a significant impact on an automated system. And if it's creating a defective film, it will repeat that process part after part after part, just the same as it can repeat a good part. So yes, maintaining viscosity by maintaining temperature is essential in automated systems. Does that help?
Yeah. Ravi, do you want to add anything here? Your voice is not
Mike,
so good.
there are many times the customer do mentions that. Am I audible?
Yes, please proceed. Yeah.
Hello. Am I audible? Yeah.
Yes.
Many times customer ask, we have got a temperature variations throughout the period actually, right? And as you rightly mentioned that they are doing the first iteration at the beginning of the process, and then throughout the day they have been using it over there. But how do they can get insight about the consumption pattern for this when with the temperature changes and effective part of it actually over there?
Obviously, if your pattern is changing width, you're going to have a change in deposition. So as your pattern gets wider, you're likely to have a lower film deposition. And the reason is that as that pattern widens, you're going to get more overspray. Overspray equals waste. And your goal has to be to concentrate as much of your coating on the part as possible, but at a controlled rate so that you get the proper 25 to 30 micron film build. So yeah, that change in spray pattern has a big impact on how the film is applied and how much of the fluid is wasted.
Thank you.
This is a great question. Do I have to change my formulation to apply automatically? And the answer is no, not necessarily. But that being said, if you're bringing in, say, the Hemlock 220, and you're adding solvent to it and mixing it, whether you're adding 30% or 35% will change the viscosity of the fluid. So we find that while you can use the same formulation, many of our customers find it advantageous to have the solvent added at the supplier when the fluid is formulated so that it comes in ready to use. And that way, there are no adjustments and no measurement errors introduced into the process. The material always comes in the same from the supplier when they're formulating it. So it gives them an added level of consistency. So do you have to change your formulation? No, you don't. But you may choose to change where your solvent is added so that your formulation is more consistent.
Okay, now move to the next question.
Now, Mike, sorry, Peram, I got in relation to this one particular point, many times the manufacturer defines the formulation type of it actually over there, right? But we do not follow that and try to face the problems what we have been talking over there. So you rightly mentioned, Mike, that whenever I'm considering the without changing my formulation and by appropriate addition part of it, I'm able to achieve the desired quality. So here, many times people do ask, I'm using maybe 60% and 60% solvent and 40% of the adhesive. The solid content by doing such kind of things and all is a very important and prominent parameter which we are neglecting into that actually.
Very true.
By so much of addition of the adhesion solvent, I'm changing percentage into the system, and that is creating a problem. And this problem may not be able to be over there unless until the failure understood by it many times across for the root cause analysis, right?
Correct. It's as we showed on the solvent continuum. There is a recommended solvent level and viscosity that, for instance, Parker Lord.
So this formulation suggested by the very important, and that should be kept in mind by always by the users actually.
Correct.
Mike, would you like to summarize what he asked so that for the audience, because sometimes we had a disturbances with this audio. Can you put together?
I'd be glad to.
Yeah, please. Thank you.
As we pointed out with the solvent continuum, there is an optimal range for solvent addition to achieve the design viscosity for film build. And as I pointed out, all solvent has to be removed during the cure process. And when you have excess solvent, it's excess cost, it's excess processing time, and it also creates issues with film build because the film doesn't get as much time to settle and become flat when it's trying to pass solvent through the surface. So the goal is to minimize that solvent and optimize the cure. And again, as you add more and more solvent, you add more and more cost, but you also add more defects with adhesion, with film consistency, with solvent pop, things like that. So yeah, when you're adding excess solvent, you're probably creating significant process problems with your final part. And so you don't have to change your formulation, but again, there are many times when you want to change your formulation to get better outcomes. And as Ravi pointed out, it comes down to root cause analysis. As you start looking at the ability to reproduce the same pattern over and over again with your automation, then you want to optimize your formulation to get the best outcomes, not just from the spray process, but also from the cure process. So the parts that are coming out of your line are ready to ship rather than ready to rework.
Okay, let's move to the next question.
This is a really good question. Summer blends and winter blends. Summer and winter blends are a symptom of viscosity issues. And it's an admission that your viscosity is changing as a function of the ambient environment around you. And so the beauty of this, when you add temperature and viscosity control, you no longer have to have summer and winter blends. And the question is, when do I switch from my summer to my winter blend? And when do I switch back? I get crossover days in the spring and in the fall when neither one is really perfect. And so how do I handle those? And the answer is, with temperature and viscosity control added to your automation, you don't have to choose. You always use the same formulation, the optimal formulation, and you bring it to the same temperature independent of changes from season to season. That's a very important point.
Okay, let's move to the next one.
In fact, in addition to that, I would like to add, Mike, about hello?
Proceed. Yeah.
I would like to add one more point here, Mike, actually. Especially in a place like India, we have got temperature variations into the day-to-day manner also, actually, or region to region. If you go to Delhi side, during the winters, the temperature would be ranging between 15, less than 15 also. Or if you go to the places like where Rajasthan or a place like Dubai, I remember I was there in Dubai, and the atmospheric temperature was more than 52 degrees centigrade. So you can imagine kind of the variations which would be happening as a result of this. It's not only restricted to the summer or winter, even the day-to-day manners are also changing over here. And to make it this more sustainable, this process as such, you need to really reduce the solvent usage part of it. And from that perspective, this temperature control is one of the best as far as I understand from this, actually. Temperature control at the point of dispensing. Yeah.
This is should I place my automation in an environmentally controlled room? And this is a common practice. And the answer is always, yeah, it's a good idea to have your automation in a controlled area. But often, by placing the automation in an environmentally controlled room, we then assume that our temperature is consistent. But if we think about the list that I showed of things that change the temperature of the fluid as it's being sent to the point of dispense, things like pump pressure and shear, agitators, things like nozzle shear, and even fittings and hoses and bends in piping, they all add shear to the system. And shear equals friction, and friction equals heat. Just rub your hands together. That's friction, and your hands will get warmer. The same happens with your fluid. So even though you're in a temperature-controlled environment, which I think is an excellent idea, it's just another variable that you control. You can't assume then that your fluid is at the proper temperature or at a consistent temperature. You may be bringing it from a storage room where it's much warmer or it's much colder. And then you bring that in and introduce it in your process. And it takes time for that material to equalize with the environment. And time is the enemy of all manufacturing processes. We want to spend the minimum amount of time manufacturing our parts so that we can ship them on to our end user. So the trick to an environmentally controlled room is to know that it is a good process variable control, but that it is not the best overall solution. It's part of the solution. It's not the complete solution.
I would like to give one example by one of my customer over here, actually, and wherein he has maintained the temperature to the tune of 23, because he said that Lords has said that you want to have the 23 degrees centigrade. Okay, so the entire kitchen, paint kitchen, was circulated. He has kept it into the air conditioned room by maintaining a 22 degrees centigrade temperature. And he had taken out the piping and all to the paint booth, this particular, and he had used a pump and all, but still he was getting a failure where our machine was kept over there. So he said that there is some problem with your machine. Usually such problem should not be there. But I said, okay, let's he had maintained even the temperature of the chamber also, where the machine was kept it over there. The robot was there. Given the concept of this controlling temperature variation at the point of dispensing, and due to which the blistering problem was very frequently happening over there. When an environmental control room and all, this reminded me, and when we started looking into the, we realized that the root cause analysis or the process validation point of view, paint kitchen, the temperature of the paint shop or the was about 22 degrees centigrade, or even the temperature of the chamber, which was, but the temperature at the point of dispensing was to the tune of about 32 degrees centigrade. So obviously, and the solid content which was coming to the substrate was in a minimal area, and they were facing it over there actually.
Yep.
Where, and due to which this typical problem of blisters or the pop happening with them actually. So this is just to add into this actually. Sure.
Great example, Robbie.
Okay, let's move to the next question.
Okay, what is the effective way of painting the main plate and maintaining effective, consistent thickness of spray bushing using a sponge dipped with Hemlock? That is a much more difficult control. There you have to control the pot, and that can be done. That is clearly an option. There's many ways to do that. Manual application by brush or sponge is difficult to get a good, even film deposition on. This is the reason that people go to automation in the first place, and that's about the only way that you're going to get good, consistent thickness. Okay, spraying is a much more controlled process than brushing or sponging. So, and it's also much easier to automate, though it is possible to use a brush coat or a sponge coat where the application is controlled by rotation speeds and things like that. So there are ways of doing that, and it's clearly an option to automate that. But if you're doing it with as a manual process, then your only real option is to control the temperature of the fluid that you're dipping into. So there's a lot of variation or a lot of variables there to be considered, but clearly you'll get improvement when you automate.
Very true, actually. One of my customer had come out with the requirement saying that, okay, I would like to do the automation with the sponge coating actually, okay, or the brushing kind of thing. I said, okay, fine, no problem. I studied that process, and what I realized is that the parameters of the job rotation, like job rotation, then the pressure of a brush or the pressure of a sponge, which is getting onto the component over there, and the linear speed. So these are the very important parameters, and one try to neglect it over there in the process of achieving 100% efficiency actually. Why people are typically going with the sponge dipping or the dipping applications? Because the efficiency is much better as compared to the spray application. But the consistency and the coating thickness aspects are one of the limiting parameters over there actually. And that's very importantly the question as you are asked, the consistent thickness is a typical problem you are going to face the always actually.
Okay, let's move to the next question.
Go ahead, Ravi.
Yeah, basically, dry coating, as I was just mentioning it over there are two types of lubrication coating. When you are referring this dry coating, or I'm referring it to the lubrication point of view, actually. Uh, Especially when you go for the wet or the dry, these are the two types of coating which are usually being applied for the rubber components or the metallic components as well, actually. Like wet type of coating is basically oil or the grease. These are the two major. Whereas for the dry coating, usually you go for the this dry film lubrication or the talc. Many times talc has been used, especially I will give the example. Till today also, especially for the refrigeration air conditioning coating application, for the heat resistance applications, the tubes are being coated with the rubber components over there. And this entire tube is coated from inside with the dry powder. Because if you can imagine, maybe a 1 to 2 feet length, you have to insert that tube on a tube, that rubber tube, and that is going to create a problem for you. So this is usually is called as the dry tubes, actually, dry dry coating. Normally, dry coatings are the better health and safety used components over there, and they are more durable, the cost efficient, and environmental friendly. And that's the reason many times the dry coatings are being used. Yeah, this is many times what is the type of material, what is the type of manufacturers who are there, actually. This is the big question people do ask. So as far as I know, since this entire process was built up by the European and the American industries, so most of the people are from there, actually, like 3M or the Lords. Lords also has got this particular type of material. Then from European side, you got a Fuchs, Xylan, right? So such kind of manufacturers, and the basic principle remains same. The combination of the solid powder or the solid lubricant, then the binders, and added with the solvent or the water, depending upon that, the fluid will be available for you, and which can be applied. Now there are many more ways of doing this dry these lubrications also, wherein the spray lubrications are also there. The spray, just like a spray bottles, which are readily available, and by applying it can be available over there. But those are very expensive, and that needs to be utilized only when the specific area where the another component wherein the your O-rings or the oil seals are being fitted over there. So the especially you look at it, the Lords or Fuchs, these are some of the names which are readily available. Xylan, then Moon. So these are certain names which are available, and these are available into the industry. Especially, you can just Google it. You'll be able to come across many such manufacturers, actually. But at the same time, you should be able to try to identify, depending upon your application requirements and the utility. Say, for example, if I do not require a high temperature, but I want to have the chemical resistance, then you should be able to go through the MSDS defined by the manufacturers, and based on these parameters, you should be able to choose and select it over there. Yeah, the general characteristics are very important, actually. As we have been talking about it, there are different characteristics. Just before answering this particular one, I was answering the question prior to this. Apart from the force requirement or apart your wear resistance and all, you should be also able to identify the characteristics like the temperature sustainability, then your chemical resistance or the chemical composition, oil resistance and all such kind of things we should be able to remember, especially for the molybdenum disulfide, whether you if you do not require to go for the uh, uh, what you call your colored components and all, then you will be able to utilize the molybdenum disulfide also. Then even the solvents which you have to use it over there, especially for the very heavy loads applications and all, one has to go for the solvent based applications of the dry film lubricants. But normally for the rubber application or the rubber components and all, water is being utilized, and that is the most acceptable methodology which has been used into the industries actually. You would like to add anything, Mike?
No, I think that's fine.
Yeah, it's another question here. What are the conditions for the application of dry film coatings?
Yeah, this is very important. As I rightly I had just described the surface, typical surfaces. This is the most important condition. One has to be very importantly thought of it actually. Compared to the conventional lubricants, solid film lubricants are the perfect additives or the alternatives following this particular kind of processes and all. So the typical surfaces is a very important aspect of it. One has to keep it in mind. One can utilize the solid film lubricants on all kinds of the surfaces, all kinds of, not only rubber or not only metal and all, which could be utilized for everywhere. If one wants to extend the service life and long-term lubrication, then the perfect choice is the dry film lubrications. Then the extreme environments. I remember one of my customer who is manufacturing the brake cylinders, and he has been facing some problems related to the typical behavior of the O-rings or the oil seals, which are being used into that application. And then where the sustainable, apart from the sustainability, the behavior of the rubber with reference to the chemical, that was his problem. So the most dry coatings can function in extreme environments and with the high speed pressure and the temperature. This is very important. Liquid lubricants has got a limitation which can fail actually. Okay, but many cases the conditions are fulfilled. These conditions will be fulfilled by the dry film lubricants actually. Then the reciprocating motion. This is also another area. In the absence of, I just mentioned, especially for the cylinders, hydraulic cylinders or pneumatic cylinders and all, if the oil assisted application and the reciprocation motion is there, then this will perfectly work very well, the dry film lubricants. But in the absence of that, it has got the limitations. It has got a limitation and the failure would be more. Though the behavior for the wear resistance and all is very good for this, but that can fail very often actually. So these are the certain conditions one has to keep it in mind while considering the application point of view actually. Conditions.
Yeah, the conditions and characteristics are very similar. You're looking at what is the lubrication capacity that you need? How much friction reduction do you need? You need to be compatible with the substrate. You need to be able to withstand a given temperature range and exposure to water or solvents or other things. So the conditions and the characteristics interact with one another. to mandate the right material for application, right?
Absolutely. Very true.
PTFE,
Yeah.
that's Teflon.
PTFE.
Yep, that's Teflon.
Yeah, please, Mike, you can answer if you want.
No, I mean, it's quite simply, PTFE, polytetrafluoroethylene, is PTFE, and that is the chemical name for Teflon. And we all understand Teflon as being very resistant to chemicals, very good lubricant. And, you know, it's used for everything from stopping foods from sticking to your cookware to greasing the axle of your car and maintaining a good slippery surface. It is a common replacement for silicone. So from a lubrication standpoint and from a durability standpoint, it is an outstanding lubricant.
Absolutely. Probably you must be also knowing, whether you know or not, I don't know, but this was by accidental, this particular product has been evolved into the lab. In America, the scientists were working out with some material and the chemical which was coming out, the combination and all, and suddenly they found it out, the PTFE or the polytetrafluoroethylene, and wherein they did try to find it out that, oh, this has got the fantastic wear properties, it has got the fantastic temperature resistance and all such kind of things, and this is by accident, and then it was termed and named as the PTFE. Of course, the brand name or the manufacturer of this have been very well established over the period of time, and that has been utilized by the dry film application, the dry film and the solid lubrication, wherein they can perform a significant role. Because the PTFE is a white color, it can accept the pigments, and by adding the pigments, one will be able to have a variety of different colors. And in fact, the ASTM has given one insight to the manufacturers that you should be able to utilize this color coding for identifying the type of O-rings, maybe if it is a application wise, or even for the rubber content point of view also, actually.
I think you covered that pretty well with your prior explanation. You know, the ability to differentiate between applications, between inlets and outlets, so that fittings don't get reversed and things like that. And again, we talked about the characteristics and the conditions that determine what dry film lubricant you need. So I think we've covered that pretty well, don't you, Robbie?
Yeah. This is also another good question, actually. How to select the dry film lubricant with the pigment, actually, right? The forming a dry film lubricants with the resin binder is the same as forming the corrosion prevention coatings and the paints. Especially why you do go for the painting application for the substrate, just to do the corrosion prevention, right? So the same role is being played for the dry film lubricants, actually. So when needed, lubricant functions as a pigment and determines the typical nature of your application point of view, actually, over there. The color aesthetics is very important for the application point of view. The formation of the film is helped by the lubricant pigments, and the lubricant pigments separate the mating surfaces that are in relative motion. If you recollect, I had shown you a typical photograph wherein the coating, after a coating application, how the it gets mixed up with the surface, rolling surface part of it over there. So which can guarantees the corrosion and the wear resistance. So this selection of the film lubrication with the pigment is a very important aspect as compared to the only black color, that is the graphite or the molybdenum disulfide. Because when especially with the black color, you cannot add any additional color over there, and that is one of the limitations of that particular dry film lubrication application. And with the PTFE, you are able to achieve these features, and you can achieve the corrosion resistance part of it with the pigment addition actually.
That's a really good point. Every process, every coating process must start with a clean surface. I think Ravi did a great job in his presentation on dry lubricants.
Absolutely.
About demonstrating the importance of cleanliness. Obviously, if there's contamination on your surface, when you go to bond to it, you will bond to the contamination instead of bonding to the surface. So surface cleaning is extremely important. And that applies in both the bonding and overmolding applications and also in the dry film lubricants. I spent less time talking about surface preparation, but it's extremely important. If your parts are dirty, your process will not perform and give you the outcomes that you're looking for.
Absolutely, absolutely. Typically, I remember this kind of contamination. Because of contamination, the bond failure is the persistently happening with one of my customer. I remember this is a story about way back in 2004, 2005. There was a typical the suspension bushing. It was being manufactured by this customer, and it used to get the failure. He used to do the appropriate type of phosphating and all, but the salt what he was using, it used to be resistive to the Hemlock type of things and all of that, and it used to create it used to absorb the typical solid content which used to be happen over there, and it used to leave out the improper bonding over the surface over there. When we try to identify uh, the area or the factory which was all the time coming with the dust particles and which was going on to the phosphated material over there, means usually it is claimed that okay, immediately after phosphating one has to do the bonding, or the maybe especially for the PTFE coating also, immediately after the cleaning and the washing application, without touching with your hands, you have to do the coating application over there, whether it's a bonding or the coating. And because even by just by touching with your hands, you are going to create a dent with your fingertips, your moisture of your hands, which is going to affect your bond strength also. So this is very important, and this point is always neglected many customers over there. So try to improve upon that. This is one of the aspect when we do the analysis of the process. We do help the customers for the analysis of your current process and the improvement process point of view. So this is one of the important aspects, and this can affect very badly to the product quality of your application actually. It may be a Hemlock, be a PTFE, be a molybdenum disulfide, you name it. The way temperature was one of the important parameter what Mike was talking, it is equally important parameter for the contamination or the contamination free substrate for the coating application for you. This is a very this is in continuation with that actually. The cleaning process when we call about it. Many times people do just wash with the components, or just with the after doing the phosphating, they will keep it for a longer period and then do the bonding part of it and all over there, right? But they do not understand the impact which is happening as a result of by keeping it for the just for the sake of over the period of time and all. So the surrounding temperature, which is also cleanliness part of it over there. If I'm using the cleaning water before rinsing with the hot rinsing and then doing the plain water rinsing and all, then probably I will be able to remove the very fine particles which are available, or the what you call the external bio particles which we cannot be able to see by just by naked eye and all, that they can be taken care by the temperature of that. Then also the agitation, just by dipping the components is not going to help you out. So the by proper agitating and all, this component should be cleaned or the washed before it goes into the next step actually. Obviously the chemistry, whether it's a alkaline water or any salt has been added into that, or the any type of chemicals which are being utilized for the cleaning application, and after doing that cleaning, whether you have been doing it proper appropriate treatment for the rinsing applications and all, this is very important. And last but not the least is the time, how long you are keeping the component for the cleaning, how long you have been taking the time. So these are the four major parameters one should be able to keep it in mind. And acronym I would like to say is it's a TACT. I always use the word TACT. The people are trying to utilize this TACT. T stands for the temperature, A is the agitation, C is the chemistry, and T is the time. So these are the four parameters one should be able to be remember into that actually. Most important thing I would like to mention here, that I am referring this discussion with the substrate preparation for the chemical bonding or the PTFE coating actually. This is one of the important question actually. I would like to answer here, that many times people are not aware about the process, and due to which they are reluctant to adopt this particular type of now especially I'm referring it to the people who have been and all, still they have been finding very difficulty in understanding this requirement. The statement of requirement or RFQ is not properly read, because they do not have the clarity about the process. One, they do not have the clarity about how are you going to test, how are you going to check whether this proper coating has been done or not. There are different methods which are being suggested by STM, that you should be able to adopt it over there. Try to understand the requirement given by the customer. Many times the customer only specify that we would like to have the dry film lubricants. That's it. But it is up to you, looking at the application, depending upon your requirements of the severity of the components where it has been utilized, you should be able to select and identify the right type of uh, uh, solution, or you can say the material being utilized for the application. Whether you would like to have the colorless or the with the color, means pigment applications and all such kind of things will be very important over there. Also, many times the costing of this particular application is another area which needs to be given to people over there. Somebody will be saying, okay, I'm selling the O-ring at the price of just few cents. Okay, almost $1 for doing the coating part of it. Why? But by doing this kind of things over there, this application and the costing are need not necessarily the same thing. As you go on increasing the quantity and all, the automating the price will be coming very low. So these are certain things which you should be able to remember. Obviously, the testing and related aspect are also equally important, and you should be able to get little aligned with the ASTM standards or the some of the customers like Volkswagen or the BMW, they have got defined their own standards for the testing and all. So which you should be able to utilize it, understand those things, try to get acquainted with the terminologies and terms which are being used into these applications and all. And then probably this will be one of the best opportunity for you to enter into the market very effectively and efficiently. Because as of now, there are very few players who are dominating this particular market of dry film lubricants, and probably which you could be one of them, and experiment with this kind of technology, and by adopting it more effectively and efficiently, you can be the important player for the companies over there, customers.
Yeah, I think anytime you're talking about automated systems, the big barriers to entry are the costs up front and the time involved. And probably the other one is status quo. If I'm manufacturing parts today, why should I change from that? Obviously, when you look at cost, the upfront cost is often a barrier because people don't look beyond the upfront cost to what they'll see after the automation is in place, the improvements in quality, the improvements in throughput, and all of that. So that's all very important. And then the time to implement automation is also a barrier because you've got requirements for your customer. You've got demands that you need to meet, deliveries that need to be met. And if you need to be down for a period of time to install the automation, that can be a barrier. So there are barriers out there. All of those barriers are addressable. You can fix those problems. And so you need to work with your automation supplier to make sure that you address those issues right up front and as part of the program.
Yeah, thanks, Mike. Reminding me on one particular point actually related to the automation and the process actually. The process is the very important barrier for this particular entry for the new entrants actually. Many times they really do not work, they do not understand the process which is required to be adopted for the coating application actually. Maybe for the FKM, it could be the different application, where for the NBR, it will be different application. The process, I mean to say the process, when it refers to the process. For the same spraying application, the process would be different. And what is that difference? You should be able to understand and define, do the design that process well in advance before you start the actual coating applications and all. Many times the automation players are a little reluctant to provide the necessary processes to the customers actually, with the assumption because they are the process owners. That customer is very well aware about the processes, but at the same time, the important perspective, adopting that particular process and making that process workable, very important role of the automation player or the automation manufacturer. And while you choose the right type of automation player, you should be able to ask the question to him to help me out for the process or a process for this application, which can be taken up into the next level actually. And once you are established with the process and all, you can play around with a very effectively and efficiently with this kind of processes actually. This is what I can tell you.
What are the common mistakes on application of bonding agents and the best practices for rubber to metal parts? And I think we summarized those pretty well here. One, start with a clean part. Two, make sure that all of your coating for your bonding agents are consistent, that they are smooth and even, that they are within the parameters for film build that are set forth by the bonding agent supplier. And you've got to make sure that the quality is there long before you ever get to the overmolding. Just the bonding agent itself, primer if you're using it, plus the, for instance, the Hemlock that we showed, has very specific parameters to maintain a strong film that provides a good surface to bond to. So cleanliness, consistency of film, those things are very, very important. And we often forget, as Robbie pointed out, we may clean in a batch and then set those parts aside before we process them. All the time that they're sitting there, they're getting dirty. And so we clean them, we assume they're clean, and yet our process has introduced dirt and contamination into the process before we finalize the application of bonding agent and then the overmolding process. So these are, the tight process control is extremely important, and you've got to make sure that you follow the steps. And like I mentioned, time is the enemy of all manufacturing processes. You want to move as quickly as possible from one step to the other. You want to move through your process from start to finish consistently and without interruption, knowing that each step in the process is controlled and prepares the part for the next step. And so things like I mentioned, cleaning and then storing and waiting, those are common mistakes that result in failure, even in a well-controlled process.
Here I would like to add a few more points related to the process actually. Okay, in any kind of bonding application process, one is the fluid preparation process, second is the fluid transfer process, and the third one is the fluid application process, and obviously the last but not the least is your temperature, means the drying application. Okay. Now, many times, depending upon the type of process, whether it's a dip spin or the spray application or the brush applications and all, one has to be very, very ensuring that the substrate preparation, the way importance we discuss about substrate preparation, it is equally important to prepare your fluid also. The fluid preparation is very important. You need to do this. It needs to be continuously stirrer should be there involved into that. I'll give an example. In one of the customers end, I had seen he was using the deep spin application, and in the morning he used to top up with the solvent and the adhesive, and throughout the day he used to maintain it over there without any stirring. When I saw that he is using that only whenever the stirring used to happen only when the drum used to rotate inside the tank. That was enough according to him. But no, that was not at all enough, because the solid content will be getting accumulated at the bottom of the tank, and even with the one-time circulation or one-time rotation of your drum inside that tank would not be creating the enough solid content available for your substrate. Similarly, your for the spray application, the gun parameters, what I had just mentioned few minutes back, that is related to your nozzle diameter, then the gun angle, then the your number of clicks or the flow of the gun. So these are the different parameters one has to remember, and these are the common mistakes people do maintain, create, and then the for the better and the effective coating of the applications, metal rubber bonding and all, these kind of process parameters are going to be responsible for making the improper process for you.
Okay, guys, so that's the end of the discussion on the rubber bonding and coating. Thank you very much, both of you, Michael and Ravi. We end this session here. Before we end this session, may I ask you to give your final remarks to the audience? Ravi, please go ahead first.
Yeah, this is this dry film lubrication is the need of hour, and there are very few players who are available in the market. And probably by choosing this appropriate method, by getting little more knowledge about this process, by choosing a right type of supplier, you will be in a position to enter into this market very effectively and efficiently, and which you can capitalize this particular and try to be number few amongst the top players of this particular process part of it over there. So if anybody would like to have any information or more insight about this, you are always welcome to get in touch with Mr. Peram or through him, or as well as you can contact me also, actually. Thank you.
Thank you, Ravi. Michael?
Well, I think it's interesting that we're covering two very different materials here, very different functions, and yet the importance of process and consistency is clear for both of them. And so you need to pay attention to that. What's more, our customers are becoming more sophisticated every day. They are asking for higher quality, fewer rejects. They want better parts. They want more consistency. And they are increasing their specifications every year. And if we're going to meet those specifications, it's going to require that we take the steps necessary in our process to make our process predictable and repeatable. And it's going to be nothing but more demanding as time goes by. And Ravi talks about the opportunities there. Those are very important. But remember that only those who are able to produce are going to be able to take those opportunities. And the question is, if you're not consistently improving, will you be able to maintain your current business? Not just add more, but will you be able to maintain your current business, or will your customers demand more and take their business elsewhere where they can get it? So you're really talking about protecting your business as well as improving it. That's all I got. Thank you so much, Param. I really appreciate this opportunity.
Okay, thank you guys.
Thank you, Mr.
Michael. Thank you, Ravi, for joining this session today on the rubber bonding and coating. Excellent, presentations, as well as the extended discussion on the various important issues through the question and answer session. Thank you very much, both of you. Appreciate the time today.
Thank you.
Thank you. Bye-bye now.
Bye. Bye.
Okay, that's the end of the discussion on the episode today. And if you want to watch this session again, you can always go to YouTube, on YouTube Technobi channel. You can check it out, this session again. And also that if you'd like to watch any other past episodes, you're welcome to check on the Technobi channel, please. Thank you all for joining this episode today, and I'll see you in the next episode. Bye-bye for now.